Hello everyone, I'm Siriji from Sri Venkateshwara College of Engineering, studying in 8th SEM, Department of Computer Science and Engineering. I'm here to discuss about the topic Raspberry Pi. The contents are Introduction to Raspberry Pi, Hardware Layout, Operating System, Configuration to Programming, Wireless Monitoring Temperature System. Introduction to Raspberry Pi. The Raspberry Pi is a series of credit card-sized single-board computers developed in the United Kingdom by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools and developing countries. Several generations of Raspberry Pi have been released. The first generation, Raspberry Pi 1 Model B, was released in February 2012, followed by a simple and inexpensive Model A. In 2014, the Foundation released a board with improved design in Raspberry 1 Model B+. Improved A+ and B+ model were released a year later. Raspberry Pi Zero with smaller size and limited input-output and general-purpose input-output abilities was released in November 2015 for $5. Raspberry Pi 2, which added more RAM, was released in February 2015. Raspberry Pi 3 Model B released in February 2016 in bundled with onboard Wi-Fi and Bluetooth. As of 2016, the Raspberry Pi 3 Model B is the newest mainline Raspberry Pi. These boards are priced between $5 to $35. Hardware layout of Raspberry Pi. The diagram shows the architecture or the hardware layout of the Raspberry Pi. It includes processor, the Broadcom BCM2835. System on chip used in the first generation Raspberry Pi is somewhat equivalent to the chip used in the first generation smartphones, which includes a 700 MHz ARM1176JZF S processor, video core, IV graphic processing unit and RAM. This has a level 1 cache of 16 KB and a level 2 cache of 128 KB. The level 2 cache is used primarily by the GPU. The Raspberry Pi 2 uses a Broadcom BCM2836 system on chip with a 900 MHz 32-bit quad-core ARM Cortex A7 processor with 256 KB shared L2 cache. The Raspberry Pi 2 uses a Broadcom BCM2837 system on chip with a 1.2 GHz 64-bit quad-core ARM Cortex A53 processor with a 512 KB shared L2 cache. Power source. The recommended and easiest way to power the Raspberry Pi is via the micro USB port on the side of the unit. The recommended input voltage is 5 volt and the recommended input current is 2 ampere. SD card, secure digital card. The Raspberry Pi does not have any locally available storage accessible. The working framework is stacked on a SD card which is embedded on the SD card space on the Raspberry Pi. General purpose input-output. General purpose input-output is a non-specific pins on a coordinated circuit. Arduino is an input or output pin which can be controlled by the client at runtime. GPIO capabilities may include GPIO pins can be designed to be input or output. Input values are meaning normally high is equal to 1, low is equal to 0. Yield values are writable, meaningful. Input values can frequently be utilized as interrupt request. This diagram shows the main blocks of Raspberry Pi. DSI display X. The Raspberry Pi connector S2 is a display serial interface for connecting a liquid crystal display panel using a 15-ribbon cable. Audio jack. A standard 3.5 mm TRS connector is accessible on the RPI for stereo sound aid. Any earphone or 3.5 mm sound link can be associated straightforwardly. Status LEDs. There are 5 status LEDs on the RPI that demonstrate the status of different exercise. OK SD card access. Power 3.3 volt bar, FDX full duplex LAN, LNK link activity LAN model P5, Ethernet port is accessible on Model P and P+. It can be associated with the system or web utilizing a standard LAN link on the Ethernet port. CSI connector. Camera serial interface is a serial interface outlined by the Mobile Industry Processor Interface. Organization together went for interfacing cameras with a portable processor. HDMI, High Definition Multimedia Interface to give both video and sound yield. Operating system of Raspberry Pi. Various operating systems can be installed on Raspberry Pi through SD cards. Operating system not Linux based, operating system Linux based, media center operating system, audio operating system, Recalbox. In operating system not Linux based, RISC OS Pi, a special cut down version RISC OS for 16 MB cards and larger for all models of Pi 1 and 2 has also been made available. FreeBSD, NetBSD, Plan 9 from Bell Labs and Inferno, Windows 10 IoT Core, a no-cost edition of Windows 10 offered by Microsoft that runs natively on the Raspberry Pi 2. Operating system Linux based, XPN using Kodi Open Source Digital Media Center, OpenSUCE, Raspberry Pi Fedora Remix, Pidora, another Fedora Remix optimized for the Raspberry Pi, DietPi, CentOS, OpenWRT, ArcOS, NARD SDK. Media Center Operating System. These include OSMC, OpenELEC, XPN, Rasplex. Audio operating system include Volumio, PiMusicBox, Rune Audio. Recalbox include Happy Game Center, Chameleon Pi, PiPlay. Configuration to programming. For configuration Raspberry Pi in Raspbian, we are using Raspbian with PiPixel desktop. It is one of the best way to get Raspbian started with Raspberry Pi. Once we finish booting, we will be in the Pixel desktop environment. Now to open the menu, you need to click the button that has the Raspberry Pi logo on it. This button will be in the top left. After clicking the button, choose Raspberry Pi configuration from the preference. Once you have set up your Raspberry Pi with an operating system, you can configure it for various tasks and program it using a variety of programming languages. Popular programming languages for Raspberry Pi development include Python, C, C++, Java, and JavaScript. Python, it is widely used for Raspberry Pi programming due to its simplicity and versatility. It has a rich set of libraries that make interfacing with hardware and sensors relatively easy. Following is the configuration tool in Pixel Desktop. By default, the configuration tool opens to its system tab, which has the following options. Change password. The default password is Raspberry. You can change it by clicking the Change Password button. Change the host name. The default name is Raspberry Pi. You can also change it to the name which you want to use on the network. Boot. You can choose from the two options and control whether Raspberry Pi boots into the desktop or CLI, that is command line interface. Auto login. With the help of this option, you can set whether the user should automatically log in or not. Network at boot. By choosing this option, you can set whether the Pi user is automatically logged in or not. Splash screen. You can enable or disable it. On enabling, it will display the graphical splash screen that shows when Raspberry Pi is booting. Resolution. With the help of this option, you can configure the resolution of your screen. Underscan. These are two options, enable or disable. It is used to change the size of the displayed screen image to optimally fill the screen. If you see a black border around the screen, you should disable the underscan, whereas you should enable the underscan if your desktop does not fit your screen. There are three other tabs, namely Interface, Performance, and Localization. The job of the Interface tab is to enable or disable various connection options on your Raspberry Pi. You can enable the Pi camera from the Interface tab. You can also set up a secure connection between computers by using short for secure shell option. If you want to remote access your Pi with a graphical interface, then you can enable Real VNC software from this tab. SPI, I2C, serial one wire, and remote GPIO are some other interface you can use. There is another tab called Performance, which will give you access to the options for overclocking and changing the GPU memory. The Localization tab, as the name implies, enables us to set the character set used in our language, our time zone, the keyboard setup as per our choice, our Wi-Fi country. Configure Wi-Fi. You can check at the top right, there will be icons for Bluetooth and Wi-Fi. The fan-shaped icon is on the Wi-Fi. To configure your Wi-Fi, you need to click on the icon. Once clicked, it will open a menu showing the available networks. It also shows the option to turn off your Wi-Fi. Among those available networks, you need to select a network. After selecting, it will prompt for entering the Wi-Fi password, that is pre-shared key. If you see a red cross on the icon, it means your connection has been failed or dropped. To test whether your Wi-Fi is working correctly, open a web browser and visit a web page. Configure Bluetooth device. We can use wireless Bluetooth device such as keyboard and or mouse with Pi 3 and Pi 0W because these models are Bluetooth enabled. In Pixel Desktop, you can set up your Bluetooth device easily. Following are the steps to configure the Bluetooth device. First, make your device discoverable for pairing. Now you need to click on the Bluetooth menu at the top right of the screen. It is aligned with the Wi-Fi button. Now choose the Add Device option. The Raspberry will start searching for the device and when it finds your device, click it and click the Pair button. Wireless temperature monitoring system using Raspberry Pi. A wireless temperature monitoring system using Raspberry Pi involves utilizing the Raspberry Pi board along with temperature sensors to monitor temperature data wirelessly. Here's how such a system typically works. Hardware setup. Raspberry Pi. Choose a Raspberry Pi board based on your requirements. Raspberry Pi 3 or 4 is commonly used due to their built-in Wi-Fi capabilities. Temperature sensor. Select a suitable temperature sensor such as DS18B20, DHT11 or DHT22. These sensors can measure temperature and are compatible with Raspberry Pi. Power supply. Provide power to the Raspberry Pi board using a micro USB power supply. Optional. A case for the Raspberry Pi and any additional peripherals like a display, keyboard and mouse. Wiring and connection. Connect the temperature sensor to the GPIO pins of the Raspberry Pi according to the sensor's data sheet. For example, if you're using DS18B20, you would connect it to the BPIO pins and configure the Pi to communicate with it using one-wire protocol. Software setup. Install the Raspberry Pi OS on your Raspberry Pi. You can download the OS image from the official Raspberry Pi website and flash it onto the SD card. Configure the Raspberry Pi to enable Wi-Fi connectivity. This involves setting up Wi-Fi credentials so that Pi can connect to your local network. Install necessary libraries or drivers for the temperature sensor. Depending on the sensor you're using, you may need to install specific libraries to interface with it. For example, for DS18B20, you might need to enable one-wire support and install appropriate kernel models. Write a Python script to read temperature data from the sensor connected to the Raspberry Pi. Use libraries like GPIO0, ADF2DHT or W1 term sensor to interface with the sensor and read temperature values. Wireless transmission. Once the Raspberry Pi is set up to read the temperature data, you can transmit this data wirelessly using Wi-Fi. Depending on your requirement, you can send the temperature data to a remote server, a cloud platform, or another device with the same network. Implement communication protocols such as HTTP, MQTT, or custom TCP/IP protocol for sending data wirelessly. Data visualization and analysis. Receive the temperature data on the receiving end, example server cloud platform or another device. Visualize and analyze the temperature data using tools like Kibana or custom built dashboard. Set up alerts or notification to be triggered when temperature readings exceed predefined threshold. Monitoring and maintenance. Continuously monitor temperature readings to ensure that environmental conditions are within acceptable ranges. Perform regular maintenance and calibration of sensors if necessary. Use historical temperature data for trend analysis and predictive maintenance. Overall, a wireless temperature monitoring system using Raspberry Pi provides a flexible and cost-effective solution for monitoring temperature data in various environments ranging from home automation to industrial application. With the versatility of Raspberry Pi and the availability of temperature sensors and wireless communication options, the system can be tailored to meet specific requirements and scale as needed. Thank you.